So in this particular video, we're going to be looking at slides 4, 5, and 6 for the Desmos practice for Module 1, Topic 1, Lesson 2, A Sort of Sorts. And what you'll be given in this one is some sort of graph, and you'll be asked to identify whether the domain of the graph is discrete or continuous. Now, the way this is going to work is you look at the graph, and here's how you can tell. If the domain is continuous, the graph will be defined by a single connected line. If the graph is discrete in its domain, that means that its domain is only integer values like 1, 2, 3, 4, and nothing in between them. And so those will be described by these points, as you see here. So this particular function has a discrete domain. Its domain only is occurring at certain points, in this case integer values, and so it is not connected. And we can select that and find that we were correct. Now we can look at this one and we see that these are connected values. So we would say that this particular one has a continuous domain because its domain includes all the locations in between the integer values on the x-axis. So this occurs at 1, or at -1, at -2, and all the points in between -1 and 2, whereas a discrete graph would just jump from one to the other. And so that is really all we're looking for on this. Now do be careful, the continuous and discrete buttons won't be in the same place all the time. Sometimes they'll swap. I want you to pay attention all the time, which is why they are that way. So that is slide 4, but we can also look at slide 5 because it's really a similar thing. Again, we just want to know if it's discrete or continuous, but we're going to use some alternative vocabulary, as it were. So we look at this graph, and we know that it's discrete based off of what we saw last time. But now I'm going to describe discrete in the buttons in a different way. So you'll see here that it says the domain is on our first option. That is that one right there. It says the domain is a set of all real numbers. When you see real numbers like that, that's your indication that this is talking about a continuous domain. And then if it's a discrete domain, notice this says a set of integers, so that would be like 0, 1, 2, 3, and not including all those points in between them. That's what creates this graph like this. So if you see a set of integers, that means that this is going to be discrete. And so you just have to know that that vocabulary is a way of talking about whether a domain is continuous or discrete, and going from that. So here we can see, forgive me, I've got to get my mouse button back. There we go. That this one is going to be a set of integers. It is discrete, and we can check our answer and see that we were correct. This one is going to be a continuous function, so we know that the domain there is going to be the set of real numbers. And notice they switched. You've got to pay attention very closely. And so we would say that that's what's going on there. So that would be slide 5. Slide 6 is a very similar thing again. We just want to know if it's discrete or continuous, but we're going to use another set of vocabulary to describe those two. And this time, it's just letters. So when you see this, it's a little hard to see because Desmos prints those off awful small. But what this is this is called a double struck Z. So it looks something like that. And that double struck Z represents the set of integers. And if you'll recall from the last one, the set of integers, when the domain is a set of integers, we say that that is discrete. And then this symbol on the other one is a double struck R, so something that looks like that, and that is for the set of all real numbers. And you'll remember if it has a domain of all real numbers, that we would say that is a continuous domain. And, be nice if I could spell, huh? And so what we're looking for in this is I just want you to tell me whether it's discrete or continuous, but I want you to know which one is represented by that terminology. So in this case, we see that this is dots, so that should be a discrete domain, and so we'll select that, and we find that, yay, we are correct. This is also discrete, but notice now they have shifted positions. You got to follow that where it goes. So there's another layer of thinking in there. And let's get a continuous one. There we go. When it's continuous, the domain is all real numbers. And so we're just using that vocabulary. Now 3 ways we can use our representative letters. We can describe it as a set of integers or a set of all real numbers, or we can describe it as discrete or continuous. So I hope that was helpful to you, and as always, if you have questions, please ask your teacher.